Okay, it's time for another artisanal Sudoku puzzle. We got Broken Square by James Sinclair. We have normal Sudoku apply. We have killer cages, and then we also have Renban lines. Oh, the digit in the cell with a shaded circle is odd. Okay. Now I know that this one is a little tougher than the ones I usually go with James, so hopefully it doesn't take me forever. All right, let's see this. All right, so this can only be, come on, there we go. 1, 2, 3, 4, 5, and 6. 4, 5, 6. And then this can only be 1, 3, 5. We know that 3 with this Renban line and in 1 through 6. So we know since 3 and 4 are in the middle, they have to be on this one. So 3 and 4 cannot be in here or here. All right, this is, all right, so then we can pencil mark in a few others. 7, 8, 9, 1, 2. Okay, so that can't be a 1, 2, so that's a 5, 6. Oh, same over here. All right, so then we can remove 5s and 6s. All right. I think that's correct. Oh, then down here, this is another 1, 2, 3. Then we have 6, 8, 9. So then we need 3, 4, 5, and 7. 3, 4, 5, and 7 to finish this box. Could it be 4, 5, 7, and then that is a 6? 3, 4, 5, and then that's a 7. 3, 4, 5, and then that's a 2. Okay. Interesting. All right, so here, 4, 5, minimum of 4, 5, 6. And then here's maximum of 4, 5, 6. Okay. This is a minimum of 5. Well, over here, 5, 6, 7, 8, 9. Okay. So this box sees 6, 7. No, it sees 7, 8, and 9. Does not necessarily see 6. But it sees 7, 8, and 9, so this has to be a 5 or a 6. And then this is 7, 8, and 9. Right? Is that right? So this box cannot be 7, 8, or 9. Yeah, okay. But either way, so then the 9 is definitely here, which means the 9 is down here. And then it goes with a 6 or 7. Okay, so then this one cannot have a 9 on it. I think that's correct. Okay, what about this? 7, 8, 9. 3, 4, 5, and 7, right? So there's definitely an 8 or a 9 on this, right? So 3, 4, 5, or 7, so it can't be that one. Yeah, then there's either an 8 or a 9 on here, but we don't know which. Now, okay. All right, this is interesting. So I should be able to figure this out and that. right? So I think either way, it's a 3 or a 7, right? Because if it was 3, 5, and 7, it couldn't be 3, 5, and 7, and it couldn't be 3, 4, 7. So we can remove the 4, 5 from this. So this one is either a 3 or a 7. So we can remove those 3 or a 7. Okay. So then this is going to be, because if this is a 7, then this could still be a 3. Okay. All right. That's something. So does this force this to be a 2 or a 6? Hang on. 1, 2, 3, triple. So that should be a 4. Which places the 4 up here. Okay. So then that's a 1, 2, 3, triple. Okay. So I think this has to be a 2 or a 6, but it couldn't be a 2. So then this would have to be a 6, which would put a 5 there and a 6 here. So that can't be 5s. 8, 9. So then this would be a 6. Then that would be a 5, which puts this as an 8, 9. So I can remove the 8s as well. Okay, so then this has to be a 5. But it doesn't go 4 or... So 4 is definitely here, we got that. Then it either goes down to 3 or up to 7, which would help us solve that one. All right. Okay, I don't know if I'm on the right path. One, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So 5 is in one of those two. Can 5 be on this? Yes, it can. All right. So if we have 7, 8, 9 up here, 8, 9, so the 8, 9 has to be down here. I think. So 6s have to be down this column, and it can't be there, so 6s are here. And it can still stay in this one. All right. Oh, excuse me. And whatever this one is going to be down here. Yeah. Could be there, because if that's a 2, it could be there. That's a 2, that'd be a 1. That could be a 2, and that could be a 2, so this could also be a 2. Okay. And then 2 could be over here as well. Oof. All right. Sixes would have to go up here. Can a 6 be in this? Yes, it can. 5s have to go down here. And can it go? 5s can no longer be in this box. In the 19 cage, I should say. So 5 is there. I think. But 5 can't go here, here. So it's here and here. All right, so I'm just going to pencil mark the rest of this box so that way I have some information. Not there. 4, 5, 6, 7. Okay, but 7's up there, so these 7s cannot be there. So if that's accurate, then this is now a 4, 6 pair. 5, 7, 8, 9. Okay. So this is 4, 6, then this is going to be a 1, 2, 3. 1, 2, or 3, I should say. This cannot be a 5 because it would need a 6 to connect to the rest of them. So the 5 would go here, then this would be a 7. 5, 7, and then that's now an 8, 9 pair. All right, so this cannot have a 7 anymore, so it puts this as a 4, 5, 6, and then 4, 5, 6. Okay. Okay, so 1, 2, 3, 4, 7. Wait a minute. So if this is an 8, 9 pair, so then this would be a 7, so that'd be a 3. So this is a 3. All right. 4, 5, 6, 7 triple. Okay, so this is a 3, so this would now be a 7, 9. All right, so then this would be a 1, 2, 3, 4, 6. Okay, then remove that, remove that, remove that, and then remove those. So 3, 4. I think that's right. All right. Excuse me, which puts that to finish off. So it's a 1, 2, 3 to go with those two. Which I don't like. Then this is also a 1, 2, 3 to finish that column, that row. So we know that the 7 has to be down here, but if that's a 3, then this would, the 7 would have to go here. 8, 9. All right. I made a bit of a jump there, but I think the logic is sound. So I'm thinking, so the 5s have to go here. So this is going to be either 4 or 6, but if this is 3, then the 4 would have to go here, and then the 4 would also have to go here. I think that's what that's telling me. So that puts this as a 6. So then we're looking for a 1, 2, 3. No. So this is a 1. Oh, didn't want that. So that's a 1, 2, 4. But a 4 has to be on here, so that means 1s cannot be, which places the 1 there. So this is now a 3. Okay. I think, all right, then I can do a 2 there and a 1 there, which solves a little bit more. 2, 1, then I can clean those up, and that 2, 4 pair, so then this is the 1. All right. I think I'm happy with that. I'm happy with how things are going at the moment. So then we know that the 4s have to be here, 4s have to be, so I know it, so this is going to be a 2, 4 pair, and then this will be an 8. All right. So this can no longer have a 1, cannot have a 9, cannot have a 5, cannot have a 7. So this is now a 3, 4, 8. So that can't be the 6, so then this is a 6. That can't be an 8, so this is an 8, and then this becomes a 3, 4 pair, which puts this as a 2. So then 2's there and 4's there, which 4, 2, 3, 4. All right, and then 3 and 2 over here, so that's a 4, 2. So this is a 6, 4. Ay, ay, ay. Okay, so then we have a 1 over here, and then this will be a 7. That's another 1, 2. Then we have a 3 here, 9 here. Puts a 7 there. Then 7s are going to be here. 1, 2, 3, 4, 5, 6. So this is now 7, 8, 9. And then this is 5, 6. So if this is, the only way that this works is if this is a 6 and that's an 8. So 6, 8. And then this has to be a 7. So 7, 9. So then we have 5 and 6. Then this becomes a 3, 5 pair. All right, so I can place, that's now a 9, this is an 8, and that's a 9 as well. 1, 2, 3, 4, 5. So we need 5, 6, 8 over here, which places the 5 here, 8 here, 6 here. So that's a 3, and this is a 5. All right, 1, 2, then we need a 3 and a 9. 8, 9, 8, 9. Dios mío, uno y cinco. 1, 2, 3, 4, 8, 7, 4, 7, 4, y último 2. Oh, wow. All right. That was good. Like I said, it's tougher than I usually do for James's puzzles, but as always, it was a good one.